Hi, I'm Kelsey Zeiser. I'm a senior editor at Light Reading, and you're listening to the Light Reading Extra podcast. And we are on site in Moline, Illinois, and we're meeting with John Deere. And today I'm joined by...
Hi, I'm Jason Wallin. I'm Senior Principal Architect for Foundational IT at John Deere.
Yeah, good to see you, Jason.
Great to have you out with us today.
Yeah, thanks so much for the tour. So we went to the Davenport Connected Factory, which is in Iowa. We keep kind of crossing borders. I got a little bit mixed up which state we're in. But that was really interesting to see some of your 5G deployments there. Can you, we've talked to you about this a bit in the past, but just for those who aren't familiar, can you give us a little history on your 5G journey and why it was important to implement in this factory?
Absolutely. No, when we think about 5G and private cellular and the place it has in manufacturing, we knew as Industry 4.0 was coming to be in that 2018 to 2020 timeframe, it was going to be critical for us to get more and more data than what we had previously had. We had lots of manual processes and didn't have as much data as we needed to have to be able to be successful in our Industry 4.0 journey. That led us to connectivity solutions that would allow us to focus on how do we get the number of devices connected that we needed to. And this was at the same time that the CBRS auctions were happening, and it was just really a natural confluence for us, especially being a technology company ourselves, using cellular telematics in our products to be able to use the same technology stack in our factories.
And I believe it was 2020 when you purchased CBRS Spectrum, or went to the auction for that, is that right?
That is correct. We bought PAL licenses in 5 of the counties where we do the vast majority of our manufacturing in the United States. And in addition to that, we also use GAA space available beyond that in other factories we've expanded to since then.
Another interesting thing I thought in the factory was the implementation of digital twins, the production and the operations digital twin. Can you talk a little bit about why it was important to deploy those?
Absolutely. And really 2 separate distinct digital twins, but help us get to the same ends with those. The operational digital twin really models the factory, the assembly processes, the manufacturing processes, the machining processes, and welding processes that we use in our factory, and allows us to more effectively plan how we lay out those factories and are more able to deliver better, higher quality machines at a more effective price point because of that. And then when it comes to the digital products, it is very important that we collect every piece of information that we can about the equipment as it's being manufactured, understanding where some of the purchase parts came from, understand how the parts were built, you know, which operators were the operators that built those parts, and then how we engage in being able to track all of that to get a true bill of material for the equipment that we build for our customers that demand really high quality equipment from us.
Yeah, it was really interesting to see the digital twins and see, you know, a replica essentially of the factory laid out, which is, I believe, 2.2 million square feet. Is that right?
That is correct. Our Davenport facility is 2.2 million square feet under one roof there. And, you know, to be able to keep track of where we have those things laid out, where we do our processing is critical to us in designing the most efficient way to make materials flow through the factories.
And then taking another look at the 5G network, your private 5G network that you implemented, talk a little bit about why it was important to move from Wi-Fi. I believe you still have some Wi-Fi, but why was it beneficial for that factory to move more to private 5G?
Perfect. Great question. And when we think back, prior to our Industry 4.0 journey, we were 70% wired in our factories and 30% connected with Wi-Fi or wireless technologies, Zigbee, those type of connectivity solutions. But what we found is we've rolled out, we needed to increase the number of connections. We had about 20 times what we did to be able to collect the data in mass that we need to be able to build both the operational digital twin and the product digital twin as we build that and have that thread all the way through the manufacturing process to our end customer. And because of that, it forced us to have that new connection method. That new connection method was clearly going to be private cellular because we can connect infinitely more devices per radio than what we were able to do with a Wi-Fi network. And again, we can do that much more efficiently because the cellular protocols built into the 3GPP systems are just so much more efficient in how they handle that than what the traditional Wi-Fi 4 and Wi-Fi 5 solutions that had available too. So just really, it was all about the number of connected devices and how we made them more robust and be able to connect and move throughout the factory.
Yeah, and there's so many parts and devices there. One thing we learned too is that there's a lot of torque devices, and we got to see, since those are connected, if there's a green light or a red light, if it's working properly or not. That was really interesting to test out as well.
Really important to give the operators good feedback, but then also very important for us to record the quality that we build into the systems there so that we know that when a customer gets a machine from us, it's going to be built properly.
Yeah, I thought it was interesting too, the idea of a birth certificate for each piece of equipment and, following the whole life cycle and being able to, have that information for the customer as well.
Being able to provide that unique experience where we know exactly what parts might be needed for that system based on the optionality that's inside there. We look at larger equipment such as articulated dump trucks or road graders, and they look generally the same, but there could be thousands of different combinations of how they're built with what technology stack inside there and then the different options that are available as well. So being able to precisely know for our customers when they go to the dealership that I need a part and we know 100% certainty this is the absolute right part that ends up on their machine.
We also learned a lot about some ways that the factory is becoming more automated. I think it's called the JADA system. Is that how you pronounce it?
Right. JADAT is our John Deere digital assembly tool, or our MES system that we use for manufacturing execution on the shop floor. It really is the work instructions that we provide to our assemblers. In addition to that, it also helps us record all the critical torque settings that we put into the equipment, make sure that we assemble everything in the right order with the right combination of parts to just ensure that we have the quality machines our customers demand.
We also got to go to the paint system, which I really enjoyed because we got to see the robotic arms painting the equipment and then working together with, 2 employees were in there kind of spot painting as well. And that was interesting to hear about how I think it was the JADA system has helped with some efficiencies or some of your automation technology has helped them better track what supplies they need to paint.
Yeah, I think a couple of key takeaways from that area there is using the vision system to make sure we understand what part is coming in to be painted at that time. Allows us to load the right program into the robots to make sure that they paint that efficiently. But one of the other key takeaways with that too is that even with the robots painting it, we still need humans to come in there, validate that everything's been covered, and provide touch-up where the robots just aren't as effective delivering paint as what the humans are.
Right. And also just to circle back a little bit to the 5G conversation, were there any challenges that you came across since it is an indoor environment? Did that create any challenges for the radios or anything that you had to reconfigure?
Actually, when you think about how our factories are built, they are beautiful steel buildings with steel roofs and steel walls in how they're laid out there. So we basically build ourselves a Faraday cage to start with that. That can have some very good benefits for us because it reduces a lot of the RF pollution that you would traditionally have to do in a larger cellular install that was more focused on a exterior as opposed to inside the building. So I think that helped us be able to do that. But the other thing is we often suffer in that same area with general public carrier coverage because of that same reason. And, we are certainly exploring that right now and very excited to see where the multi-carrier networks could be used in conjunction with CBRS to help us enhance our employees' work-life balance to be able to make sure that their cell phones work well inside the buildings too.
Yeah, so just to wrap up and build off of that, what do you see next for John Deere's 5G network? Are you going to be expanding to other factories, looking into 5G standalone? What's on the horizon next couple years?
Yeah, as we think about how this grows, a couple of things really come to mind here. First of all is building out the rest of our U.S. footprint to be able to support this this technology stack and be able to leverage that same digitalization that we've tried to do, the connectivity that we've tried to do, and then the efficiency plays and continuing to improve our processes. But then being able to take that and then also replicate that to some of our other facilities outside the U.S. as well.
Yeah, so looking forward to hearing more about that. Jason, thanks so much for the tour today and for going over, how you utilize 5G. It's been really interesting.
You bet. Thank you. And, it's just always such a pleasure for us to have folks come out and see what we get to do and how by adding the technology, we can really increase the value that our customers see in our products.
Yeah, definitely.